Alrighty. So what I want to talk about now is how to find derivatives using basic rules for differentiation. Okay? So the basic derivative rules are shown in blue on the right of your screen. I'm going to explain all of these rules to you. The first rule states that if you take the derivative with respect to variable x of a constant, we denote the constant as c, then the derivative of your constant is 0. Your derivative of your constant is going to be 0. If you look at the second rule is called the power rule. The power rule states that if you take the derivative with respect to x of x to the n power, then this is going to be n times x to the power of n minus 1. In other words, whatever your exponent for your variable x is, you just bring it down, and then in terms of your exponent, you just got to subtract 1 from it. The third rule is just a constant multiple rule. Essentially, it's the same thing. It's now where your variable x has a constant in front of it. So by this constant power rule, what you're going to do is take the constant c and multiply it by your exponent of n. You have your base x, or variable x, raised to the power of n minus 1. The fourth rule basically tells us, hey, if I have 2 or more functions or 2 or more terms, I can take the derivative of each of those terms or functions. So for example, in parts A through B, although those are singular functions, like f of x, s of t, g of x, and y, because each of those functions contains multiple terms, that fourth rule allows us to take the derivative of every single term. Now, the fifth, sixth, and seventh, and eighth rules I left blank. I did that on purpose because I just want to tell you guys what it is now. So let's first begin with the derivative of sine. The derivative of sine is cosine of x. The derivative of cosine is negative sine of x. The derivative of e to the x. The derivative of e to the x is actually very easy. It's always going to be itself, as long as it's e with strictly at the x power. And lastly, the derivative of ln of x is going to be 1 over x. Okay? So I don't know if you've seen these rules yet in your courses, but I'm at least showing you now. Here's the trick to sort of remember sine and cosine. Now, if you look at cosine, right? If you look at cosine, what letter does it begin with? A C. You see, if I replace the O with a U, right? If I replace that O with the U, it looks like I'm saying cuss, right? Curse, like in terms of a bad word, but cuss in the, Caribbean accent. Stop cussing or whatever. But anyways, cursing, right? Obviously is bad words, right? You was learning in elementary school not to curse. Well, what sign do you think goes with bad? Positive or negative? Negative. So if you look at cuss, C-O-S, essentially it looks like cuss, which we know has the idea of bad word or negative word. So therefore, its derivative is negative. So that's to help you to remember it, right? Derivative of sine is cosine, but the derivative of cosine, because it begins with the letter C or looks like cuss, it's negative sine. In fact, there's a couple of other trig functions that begins with the letter C. You have cosecant and cotangent. We're not there yet. I don't think you're there yet in your courses. But what you're going to see is that since they begin with the letter C, their derivatives is also negative. Okay? All right. And again, derivative of e to the x is always going to be itself. The derivative of ln of x is 1 over x. All right. So let me show you how these derivative rules now comes to play when I look at examples like parts A through D. So if I begin with part A, it says that my function is f of x equals negative 2x squared plus 3x minus 6. So essentially, I'm applying a few different rules here. The first rule that I can apply is the fourth one. If I want to find the derivative of this function, essentially I have to find the derivative of all of its terms. Right? So I can rewrite this as saying f prime of x is equal to the derivative with respect to x of negative 2x squared plus the derivative with respect to x of 3x and the derivative with respect to x of 6. That's my first line. The second line is saying that, okay, I am going to take each of these derivative of each terms using one of the basic derivative rules. Like, for example, the derivative of negative 2x squared and the 3x can be done by using our rule number 3, the constant multiple rule. And the derivative of 6 can be done using our simple first rule, constant rule. Okay, so here's how this goes. If you want to take the derivative of negative 2x squared, you first bring down the 2, right? So you have negative 2 times 2 times x raised to the power of 2 minus 1, and you'll simplify that. What is the derivative? What's negative 2 times 2? Negative 4. And then if you subtract 1 from the exponent, you have x raised to what power? Sure. Subtracting 1. So it's 2 minus 1, which is 1. Or just simply negative 4x, okay? Now, if you want to find a derivative with respect to x of 3x, x is raised to what power? 1, right? So I'm just going to stick that 1 there so that way we know it. So by our third rule, our constant multiple rule, you do 3 times 1 times x to the power of 1 minus 1. Oops. Okay, let's simplify this. What is the derivative? What's 3 times 1? 3. Now, we have x raised to the power of 1 minus 1, but what's 1 minus 1? 0. Anybody know what's x to the 0 going to be? 1. If x to the 0 is 1, if this piece here is going to be 1, then you have 3 times 1, which is 3, okay? And lastly, your derivative of 6, because it's a constant, is 0. Right, so just to clean up my derivative here, I say f prime of x is equal to negative 4x plus 3. Right, you don't need to write the minus 0 at the end all the time. You don't need to write the minus 0 all the time. But in the last line, you just make sure you clean up your derivative, okay? Let's just try another example. I'll do it in the similar formatting until we get used to it. So I'm just going to scroll it down. And we're going to look at part B. Part B says that we want to find the derivative of s of t. So s of t was defined as t to the third power plus 5t squared minus 3t minus the square root of pi. So essentially, I'm finding s prime of t. Now, this is just different notation, but we're applying the same thing. Instead of saying we're taking the derivative with respect to x, we now take the derivative with respect to t. And if I'm taking the derivative with respect to t, I'm taking the derivative of every single term by t. So we say d dt of t to the third power plus d dt of 5t squared minus d dt of 3t, and then lastly minus the derivative with respect to t of the square root of pi. Okay, so let's apply our derivative rules, and let's try to apply it where I'll tell you the rule, but you try to do the math mentally. So first thing is, let's take the derivative of t to the third. To take the derivative of t to the third, you apply your power rule. So you bring your power down as a coefficient of your variable t, and you subtract 1 from your exponent. So what would be our derivative of t cubed? 3t squared, very good. The first term will be 3t squared. For your second term, if you want its derivative, then you have to take the derivative with respect to t using your constant multiple rule. So you bring down the 2 and subtract 1. When you bring down the 2, you have to make sure you multiply it by 5. So 2 times 5 is 10. So this will be 10t raised to the power of 2 minus 1. But what's 2 minus 1? 1. Do you think do I need to write the exponent of 1? No. You can leave that as 10t. All right. Now, what is the derivative of 3t? It will be minus 3. That's right. Well, the derivative of 3t is 3, but because we have the minus sign in front of our derivative, we know that it's going to be minus 3. And your derivative of square root of pi, well, let's think about this. Is pi a variable or a number? It's a number, equivalent to 3.14159 and so forth. So this pi is a number. If I take the square root of pi, is it still a number? Yeah. So if I want the derivative of a number, namely a constant, that derivative is 0. So I don't need to write 0 as in my final answer. I could just say that this is going to be 0. And since I don't need to do any more simplification to s prime of t, this will be my final answer. Any questions? With this one?
No.
No? All right. Let's look at another example. In this next example that I'm going to show you, sometimes when you deal with functions, you got to rewrite the function and then find your derivative. Okay? So I'll show you with part C what I'm talking about. Yeah.
For example, if you cause negative square of 2 pi, it will be the same thing?
Negative square root of 2 pi? Yeah, because it's still a number. So derivative of a constant is a number. Okay, so for part C, we have g of x is equal, oh, this one doesn't require the rewrite. 6x to the 8th minus cosine of x plus 3e to the x. So essentially with enough practice with derivatives, right? Essentially with enough practice, you don't need to keep writing d dt or d dx. Okay, you don't need to write it all the time. You can just, if you can figure it out, then using a little bit of mental math, then you can get your derivatives. For example, if I look at 6x to the 8th power, I know I need to use my constant my constant multiple slash power rule. So what do you think will be my derivative of 6x to the 8th?
64x7.
Careful. What's 6 times 8? 48.
Oh.
Not 64. So 6 times 8 is 48. So it's 48 times x to the power of 7, right? Because you had to subtract 1 from the exponent. Now, we said this earlier. What is the derivative of cosine? Negative sign. But look, we have a negative in front of the cosine. So what happens to the two negatives? It becomes positive. So we say positive sine of x. Right, just note, derivative of cosine was negative sign. You have a negative already in front of it, so it becomes plus. Now, I said the last one is the easier of all of them, because what's the derivative of e to the x? Itself? Well, the 3 is a constant multiple, so it comes to the right. Your derivative of 3e to the x is itself. And that's your answer. Okay? So again, with enough practice, you can find your derivatives without showing much work, depending on what's the function. Right? You can just apply a little bit of mental math. All right? Sometimes you have no other choices. Okay? Like, for example, if I be looking at part D, I'll just slide back up to look at what it was. This one's a little nasty. We have y equals the square root of x minus 6 times the cube root of x plus, thank you, 3 over x squared, 4 sine of x, plus e. Okay, so I want to find essentially y prime, right? dy dx, right? So the way I could write this, I can say that, you know, we're trying to find dy dx, by the way. So sometimes you can see this in your notes. You're trying to find the derivative of y with respect to x, or you could just write it shorthand as y prime, whichever you prefer. When we get to something called related rates, I prefer when you write it as dy dx. But I'll explain, or implicit differentiation. I'll talk about that maybe like in our fourth or fifth workshop. Okay, so if I want to find y prime, before I do that, you first rewrite y using rational exponents. If you look at the first term, you have the square root of x. In order to find the derivative of square root of x, you have to change your square root to be a rational exponent. Similarly, when you have the cube root of x, you have to rewrite it using a rule for rational exponents. So, in short, this is just from pre-calc. From pre-calc, what you should have learned is that if you have the nth root of x to the m power, or the nth root of x, where all of that's raised to the m power, then you can rewrite that as x to the power of m over n. So when I have the square root of x, what is my root? What is the root of the radical? The root of the radical? 2. The root of the radical is 2. So the square root of x can be rewritten as x to the power of 1/2. Now the next term has a root of 3, so you can rewrite it as -6 times x to the power of 1/3. The third term is where we got to be a little careful with as well, because where is your x located? In the denominator. The only way that you can apply your power rule is when x is in the numerator. Well, there's also another rule from pre-calc that helps us with these exponents. You see, if you have a constant over x to the m power, you can always rewrite this as the constant times x to the power of negative m, right? The other rule that you probably learned was that if you have x to the negative m, that you could rewrite it as 1 over x to the m, where the exponent becomes positive. So essentially, we're going backwards. We want that exponent to be negative. Essentially, so that the variable x is in the numerator. So it's plus 3x to the power of -2 plus 4 sine of x plus e. All right, let's take our derivatives now. So bear with me as I do this. So if I want to get the derivative of x to the 1/2, I bring the 1/2 down and I subtract 1 from 1/2, right? So this is going to be 1/2 times x raised to the power of 1/2 minus 1. In the next term, we're going to have -6 multiplied by 1/3, because now I have to bring down my exponent of 1/3, times x to the power of 1/3 minus 1. Next, I'll say 3 times -2 times x to the power of -2 minus 1. What is my derivative of sine of x? Cosine. So because we have a 4 in front of it, we say 4 cosine of x. And the derivative of e is going to be what? Not itself this time.
1.
Not 1. 0. E by itself is a constant, so its derivative is going to be 0. Okay. Let me clean up our derivative. So for my first term, I'm going to have 1/2 of x to the power of 1/2 minus 1. Do anybody know what's 1/2 minus 1? Say again? Not 0. 1/2 minus 1. Not 1. 2 minus 1 is 1. It's a fraction. Say it louder. It's 1/2. But is my 1/2 going to be positive or negative? It's negative. So it's going to be x to the power of -1/2. One way to think about it is that, here's one way of thinking about it. Which number is bigger, the 1/2 or the 1? The 1. So when you do the subtraction, you know that the negative sign should still carry over, because the 1 is the negative number. Now, let's think about it this way. If I have one whole pizza, and I eat half of it, then what should be remaining? If I have a whole pizza pie and I ate half of the pizza pie, then what's remaining? 1/2. But because again, the 1 was negative, we say negative 1/2. Let's look at the next one. First of all, you have negative 6 times 1/3. What's negative 6 times 1/3? Well, that's negative 6 times 1 divided by 3. So it's negative 2. Very good. So the next term will be negative 2. Then you have x raised to the power of 1/3 minus 1. So let's try this again. What's 1/3 minus 1? Well, which number is the bigger of the two, the 1/3 or the 1? The 1. So we know that the negative sign should stick with into our answer. So if I do 1 minus 1/3, just think about pizzas, everyone. If I have a whole pizza pie and I eat 1/3 of it, then you have 2/3. But we can't say x to the power of 2/3. We got to say negative 2/3. Okay, now we try it again. 3 times 2, or negative 2? Negative 6. X raised to the power of negative 2 minus 1. Okay, I think that one we can do. Negative 2 minus 1 is negative 3. Right, so we get negative 3 here, plus 4 cosine of x, and then that plus 0 you don't need. Okay, let's clean up our derivative. This is a nice derivative, but one thing with MyLab is that it might ask you to, if you're doing your MyLab homework, it might ask you to rewrite your answers using positive exponents. So if you have these negative exponents later around, then you just apply the negative exponent rule that says if you have x to the negative m, it's 1 over x to a positive n. Oh, that looked like an n, I'm sorry. All right, so we say y prime is going to equal 1 over 2x to the power of 1/2 minus 2 over x to the power of 2/3 minus 6, that's a 6 there, everyone, over x to the power of 3 plus 4 cosine of x. So this example was a very challenging one, only because it required to know how to do a lot of rewrites with first finding the derivative and then rewriting your final answer.